Okay, hello everyone. In this video, going to talk about a new term called power. Okay, in last video we demonstrate a wall kinetic energy theorem, and in this video we are going to talk about the power. Okay, and in this chapter I've already introduced the work and kinetic energy, and it's all about the amount of energy. But most of and also, but in engineering, we are not only interested about the how much energy produce or consume. We also care about how much energy used and produced in a certain under a certain period of time. Okay, that's power comes from. Power is the energy used or produced in a certain period of time. So power is like the velocity and acceleration. There's the average power and instantaneous power. Okay, so average power is if during a time delta t, you produce or consume delta W energy, delta W work, you just divide delta W by delta T. That's called average power. And also we have instantaneous power. So instantaneous power means you're doing derivative of the power with respect to time. That's called instantaneous power. And from this definition, we can also understand that when you try to calculate the energy by the power, if you try to calculate energy from the power, for example, in average power, if you have average power and want to calculate the energy, you want to calculate energy, just use average power times delta T is equal to the amount of energy. Okay, and so if you have instantaneous power, if you have instantaneous power, so how to find the energy? So you just the P times delta T is equal to delta W, and then you do the integration on both sides. Okay, this the left hand side is equal to T1 over T2 P delta T. So that's just doing the integration of power with respect to time. And right hand side is this dW means tiny energy. We add all the tiny energy all together will become the total energy. Okay. So if you give you the power, if your power is a function of time, you want to calculate total power, total energy, just do the integration of the power with respect to time. Okay, there were some example in the end chapter problem. Okay, and what's the unit of the power? Okay, we use the watts, and the abbreviation is W. But I think W sometimes you were thinking is that a work or or what or something else or what? So this is sometimes really confusing. So I prefer just writing all detail. That's called watts. What's the energy of power? Okay, and it's energy per unit of time. It's energy per unit of time. And in MKS system, what's the energy unit we love? Okay, it's called joule. Yeah. In the last video, I said joule is the energy unit we use the most. We use most in MKS system. And in MKS system, the unit of time is second. So watts equal to joule per second. Okay, don't forget about it. And what is joule? What is joule? Joule equal to newtons times meter. Don't forget about it. Okay. And yeah, but in everyday life, in daily life, in car business, we heard another unit for power. It's called horsepower. It's called horsepower. Yeah, it's used a lot in car business. Yeah, when we're trying to buy a car, they always show you how much horsepower does the car have. Okay, and 1 horsepower is equal to 745.7 watts. Okay, you can do the unit conversion by yourself. Okay, and the definition of horsepower is very interesting. It's really a horsepower. Okay, when a horse lifts this object, and this object is 550 pounds, and lift this object 1 feet height in 1 second, lift this object 1 feet high and in 1 second. That's called 1 horsepower. Okay, that's called 1 horsepower. You can check in science history. That's really a definition of horsepower. Yeah, but in this class we won't use this unit. Okay, because it sometimes generate lots of confusion. Okay, so we just keep in this class. Let's keep using the watts. Um, okay, but in car business, like I said, I rarely hear people use the watts to describe the power of a car. Yeah, they always use the horsepower. Yeah, very interesting. Why in car business they love to use the horsepower rather than watts? I don't know. There may be some reasons. Maybe you can check on Wikipedia or Google. Yeah, like I said, in car business, yeah, we all use horsepower. I don't know why. No people use watts. Okay. And today the horsepower for Formula One car is about 850, I think 850 in today's F1 car, and for a safety issue. But there was a time the Formula One car has over 1,000, even reached the 1,400 horsepower. That is very horrible because with such horsepower, you for normal people, for not training people, you cannot even hold a steering wheel. Yeah, you cannot even hold a steering wheel once you push the throttle. It's very horrible. Yeah, but for the racing driver, they can handle it because that's their professionals. Okay, that's their professions. Okay, that's a power. And here I just introduced there is a unit called kWh. Okay, it's kilowatts times hours. Kilowatt times hour, and it's an energy unit. It's an energy unit. This is kilowatts atts times hour. Okay, kilowatts times hour. Because watts is energy per unit of time, so you multiply the time, it's become the amount of energy. Okay, so kWh is the energy unit. Especially you see this a lot in electric bill. The right hand side is the electric bill in Japan, and left hand side is electric bill in Taiwan. So you will all see that okay, there is a unit here. Yeah, there's a unit here in Japanese electric bill. And why the color it was wrong. In the electric bill, in Japanese electric bill, yeah, you see 80 kilowatt times hour. And Taiwanese bill, electric bill, kilowatt times hour. Okay, so it looks like it's a universal unit for energy in electric bills. Okay, so and the next we try to relate the power and the velocity because in the previous video, in previous work kinetic energy theory, we proved that the work relates to your kinetic energy difference between the final state and initial state. And the kinetic energy is a function of velocity. So work has a relationship to the velocity. So let's same thing happens in power. Power has a relationship to the velocity. So power, let's say if we start from infinitesimal, how to call this? If we have infinitesimal displacement, and it doesn't work. Okay, when a force acts over an infinitesimal displacement, it does work. It does a tiny work, and tiny work we call it dw. Dw. This d is not the distance; it's d derivative. Okay, dw. This means the tiny work done by the force on an infinitesimal displacement. Okay, so it's force times the displacement. Okay, and it's instant. When an instant force and a certain instant, yeah, when an instant force, okay, this should be instant force. Okay, instant force has to be more accurate. Okay, I finally understand this. Okay, when I do a lecture, I say that this is in a lecture. I say this could be, there could be why. Yeah, I forget about it. Okay. Simply speaking, in the lecture, I'm not 100 convinced by this formula, but I finally figured out this formula is correct. Okay, Okay, forget about it. Okay, so when the instant force, okay, when the instant force acts on over infinitesimal displacement, it does the work dw. Yes, d also means, yeah, like I say, it's not distance. It's d that means very tiny amount of work, and f dot product to displacement. Okay, and so so the so the P, the power is dW over dt. Okay, doing the derivative of W with respect to work with respect to time. So you just divide it by dt. Okay, divided by dt. Okay, and so what happened? You will become F dot. Okay, so it's so it will become the F dot dr over dt. So it will be, and this dr over dt, derivative position vector with respect to time is velocity. So it will become the force times dot product to the velocity. P equal to the power equal to the force vector dot product to velocity vectors. Okay, so once again you see the power has a relationship with velocity. Yeah, it's very similar to the kinetic energy. Like I said, kinetic energy has something to do. Work and kinetic energy. Work has a relationship with to the velocity, and also the power also has relationship to the velocity. So velocity, this physical quantity is very, yeah. The velocity, this physical quantity has a close relationship to the energy and power. Okay, that's why when we discuss some mechanical system, we are interested in the velocity, yeah, because it relates to the energy and power. Mhm. Okay, so and you might ask, why this dt only under the dr? Yeah, that's something I really cannot fully understand. Maybe if you have better explanation, please tell me. Yeah, sometimes they use this method to do the derivation, but you will face this problem. Why is dt only under the dr and not under the f? Yeah, but I'm not saying this formula is wrong, but this formula is correct. But the derivation sometimes it's really sometimes really confusing. Okay, okay, so okay, yeah, sometimes really confusing. Okay, so yeah, but this formula is correct. And next is an example of the power calculation, and I think I will show it in the next video. I will show it in the next video, and then we will finish this chapter. Okay, thank you for your watching. I'll see you next video. Bye bye.